Welcome to Ask and Learn.
Okay, well, in this problem we need to determine if the polytropic exponent to be used in an Otto cycle model will be greater or less than the isentropic exponent. And to begin solving this problem, first of all, we must know what represents the transformation for a polytropic and for an isentropic process. So we have two main equations for each one. So let's put here the polytropic first. So for the polytropic, we have that PV to the power of n is a constant, okay? And we also have the TP to the power of n minus 1 divided by n is also a constant. So we have these two equations for a polytropic process. And what about the isentropic process? So for the isentropic process, we have again two equations. The first one is PV to the power of K is a constant. And remember, K in here is the isentropic exponent, is the is the specific heat a constant pressure, a constant temperature, okay? A room temperature, sorry. And here we have the T P to the power of K minus 1 divided by K also equals a constant. So we have these two equations here, two for the polytropic and two for the isentropic. If the heat is lost during the expansion of the gas, what we know, theoretically speaking, is that the temperature of the position 4, which is the final step of the process, needs to be greater a temperature for S. And what is this temperature for S in here? This is the temperature if the expansion were reversible. So this is the expansion if we have a Carnot cycle and not our Otto cycle. So thinking about just the heat lost during the expansion of the gas, if we are dealing with a process, with a cycle that is not a Carnot, we will lost more temperature, more heat in the final temperature than if we have a Carnot. And because of that, if we have a Carnot cycle, what we actually have is that N equals K. But since this one needs to be greater, well, the answer for this is that N is less or equal the isentropic exponent. So the polytropic exponent never can never be greater than the isentropic exponent. We always needs to have that in mind. The polytropic never will be greater than the isentropic, which is never greater than the Carnot. Okay, so the Carnot, this is equal, but since a Carnot cycle does not exist, the polytropic will always be less or equal than the isentropic one. And that's the final answer. Thank